This is part 2 of our 2.2 notes. We're starting with our core concept of deductive reasoning. So deductive reasoning uses facts, whereas inductive reasoning that we used in part 1 was more of observations. So it uses facts, definitions, accepted properties, and laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form the conjecture. So some laws of logic that we use, we're going to use the law of detachment, which is if the hypothesis of a true conditional statement is true, then the conclusion is also true. We're also going to use law of syllogism, which means if hypothesis P, then the conclusion Q, and then if hypothesis Q, then conclusion R. If those are both true statements, then we have if hypothesis P, then conclusion R will also be true. So example number 4, if a figure is a square, then it is a rectangle. You know that quadrilateral ABC is a square. Using the law of detachment, what statement can you make? So here we have this conditional. So if a figure is a square, then it is a rectangle. We know that quadrilateral ABCD is a square. So this part matches our hypothesis, so this matches here with the quadrilateral ABCD is a square. So since quadrilateral ABC is a square matches the true hypothesis of our conditional, therefore we can say that ABCD is a rectangle. That's what law of detachment is. Another example would be if vertical angles, then congruent angles. So an example would be if we have angle 1 and angle 2 are vertical, we can conclude since angle 1 and angle 2 are vertical, and this true conditional, if vertical angles, the hypothesis matches this one, then we know that angle 1 is congruent to angle 2. Example number 5. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So for example, if soccer practice is canceled, then you go to the mall after school. If it is raining today, then soccer practice is canceled. So looking at these two conditional statements here, they're both true. I see that the hypothesis of this first one, if soccer practice is canceled, matches the conclusion of the second statement here. So since the hypothesis of one of them matches with the conclusion of the other one, then we can conclude that if soccer practice is canceled, or if it is raining today, then you will go to the mall. So since the hypothesis of one matches with the conclusion of the other one, you can match the other hypothesis with the other conclusion and get a true statement. Part B, let's look at this one. If a figure is a rectangle, then all interior angles are right angles. Okay? If a figure is a square, then all interior angles are right angles. We can't use law of syllogism on this one because there's not a hypothesis that matches with the conclusion. So there's no conclusion that can be made here. The conclusions match, but you want a hypothesis and a conclusion to match. Next, example number 6. says the table shows the sum of measures of the interior angles and various polygons. We know all of these to be true, that the triangle has 3 sides and that your interior angles equal 180. Quadrilateral, pentagon, and hexagon are all there as well. We want to know what conclusion can you make about the sum of the interior angles in an n-sided polygon. So for any polygon that we have. So we can make a conclusion that we notice a pattern that it's going up here. You're continually adding 180 degrees to get to the next angle measure or angle sum. So the previous angle total plus 180 will give you that next measure. But notice, if we want to write an equation here, we want to write something for the n-sided. If you take the number of sides right here, if you let that stand for n, notice if you do n and you subtract 2, then you multiply it by 180, that will give you an equation for the sum of the interior angles. So let's try it out. So for a triangle has 3 sides, so that would be n, so n minus 2 times 180, well n 3 minus 2 is 1, times 180 will equal 180. So we came up with the conclusion and we wrote our equation here to help us for an n-sided polygon. Example number 7, decide whether inductive reasoning or deductive reasoning is used to reach the conclusion and explain your reasoning. So A here is talking about the sum of digits of the number is divisible. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. The sum of the digits of the number 147 is 12, so the number 147 is divisible by 3. This would be deductive. This would be deductive here. And it's because we're using facts. We're using numbers that this is adding to 3, so therefore it's divisible by 3. So this would be our deductive reasoning. B, on the other hand, is each time you forget to do your math homework, your parents take away your phone privileges for a day. This one is inductive reasoning because it's using a pattern. It's what you observed. Next, looking at these, pause the video and then try these on your own. All right, looking at these, so number 8 here, using the law of detachment, you can conclude that angle R is obtuse because that conditional was true, and since the measure R is 155 degrees, that matches the hypothesis of our conditional. We can conclude the conclusion of our conditional. Number 9, you use law of syllogism. Since the hypothesis of one of them matches the conclusion of the other, you can take the other hypothesis and the other conclusion and match them together. So if you get an A on your math test, then you can watch your favorite actor because you get to go to the movies. Number 10, you're using deductive reasoning to show that the conjecture is true. So you have a conjecture about the sum of a number and itself. So it's saying if you add a number to itself, then the sum will equal 2 times that number. So you add x plus x. So you add a number to itself. That equals, we know that x plus x is 2x, so therefore 2x is equal to 2x because it's 2 times that number that you added together. Number 11, this one would be using deductive reasoning because it's using law of deduction. So all multiples of 8 are divisible by 4. 64 is a multiple of 8, which giving you that this part is true, all multiples of 8, since it's 64 is a multiple of 8. 64 then is divisible by 4. Go back, watch any part of the video that you need to, and thanks for watching.